Hi everyone, and a warm welcome to today's session as Agentic RAG, a free live webinar by AgileFever. I'm Sai Kumar and I'll be your host for this session. We are thrilled to have you all here. And as we deep dive into this most exciting AI topic today, it's my pleasure to introduce our expert speaker, Alok.
Good morning, good afternoon, and good evening from folks who are from other geographical areas. So today we are going to discuss about Agentic RAG. And you all know Agentic RAG is something new. Agentic itself is new. So when we are talking about Agentic AI, let's try to understand what is Agentic RAG. Now there are two things in this. One is RAG, one is Agentic part, and how they are coming together. So we will try to understand this. Let me share my screen meanwhile. Okay. So fine. I hope my screen is visible. Sai?
Yes, Alok, we can able to see
Well,
you.
yeah. So first of all, I welcome everybody. Thank you for, spending out time, like taking some time out and joining this workshop, at least to understand about agentic RAG. So I thank you all for participating and maybe, being, trying to understand this. So what are we going to do? Like, what are we going to discuss today? So this entire discussion that we'll be having would be around understanding first about RAG. What is RAG? Why do we need RAG? Very, very important here. And then, like, because we're talking about agentic RAG, so first we need to understand what is RAG, what is the requirement, and then what is an AI agent. So when we talk about AI agents, what are the AI agents? And then we will understand what is agentic RAG and how it is different from normal RAG. Like we already have RAG, so how it is different from a traditional RAG that we are having. And then we'll understand what are the core component and what is the workflow of an agentic RAG and identify important use cases. So this is like introductory sessions where we would be understanding basic concepts and we would be going through this. So this will give you some basic idea about agentic RAG, like what is agentic RAG and what are the use cases around this. So first of all, let's try to understand about RAG. Okay. So what is RAG? Why do we need RAG? Anybody would like to answer this question? First of all, what is RAG? Why do we need RAG? You can put your comments in chat. Accessing the information LLM was not trained, and yes, provide exactly. So every LLM is having a cutoff date. Like they would have been trained 6 months back, or maybe just 2 months back. And if something is happening, the like recently, if some new disease has come up, or maybe some new event has happened, the large language model may not be aware of that. Okay. The other thing would be like every organization, they have internally they are having a lot of data. Like email would be one such example. There would be a lot of email, within the organizations, a lot of data. Now, all this information they lies inside an organization, and no company, like no organization in this world, would share their data to train any large language model. Nobody will do that because their entire business is based on this. So, for example, if I go and ask ChatGPT how many leave policies I have in my company, it would not be able to answer. Why? Because it is not aware of my company leave policy. And the reason is that my company leave policy is not available on internet data. So sometimes what happens, LLMs are very, very good model. Like they are very, very good in next token predictions. Okay. We all have seen, it's very good for content creation and all. But it all is based on some sort of pre-trained knowledge. It is not like that it is having from magic. What is happening is that these LLMs, they are having some sort of pre-trained knowledge. How are they getting the pre-trained knowledge? By whatever data that was used at the time of training. So they got the knowledge from there. Now, because of this, they will be having certain limitations as we discussed, like some incorrect information, some sort of hallucinations, or maybe some sort of outdated knowledge that we are having. So it would not be able to access and reason over real-time data set. And the solution for this is to use RAG. So RAG is like a very, very powerful tool that we are having, which can enhance the accuracy of large language model. How it is doing that? So this is based on three important things. RAG itself is made up of three important things. What are the three things? The R stands for retrieval, A stands for augment, and G stands for generation. So RAG is made up of three things: retrieval, augmentation, and generation. What is happening here in this RAG entire pipeline that we are building? First of all, we need to create a vector database of our data that we are having. I'll just explain you with an example here. Just give me a minute. So when we look at RAG itself, so what you're seeing here right now, okay, the screen is not visible. So what you're seeing right now is actually a complete end-to-end how RAG is working. So first, we need some data. We do tokenization of that data. We convert that into small tokens by using some chunking methods like using a recursive character splitter or some other way, simple character splitter to prepare a chunk of the data. And once we get those chunks, those tokens, then we do embeddings. Embedding is like converting our data into a vector form, into form of a numerical values, because model will not understand the text data. All computers, they understand the binary language, zeros and ones. So text data, how do we make machines understand? By converting this into a numerical form. And embedding is nothing but converting your data into a float form, basically some sort of numerical form in n dimension space, like 300 dimension, 400 dimensions. That's what we are doing. Just to explain that, for example, if I take a very basic example of a cat and a dog, let's say this is our coordinate system 1, 2, 3, 4. This is x-axis and this is y-axis. And here we have again like all this scaling here 1, 2, 3, and maybe 4. So this is the scaling that we are having. And suppose here I write a cat, here I just mention a cat, and maybe here we have a dog. Just giving a very basic example, explain embeddings. So here you can see we have a cat and dog. Now if you want to, if you want to mark it down, what is the coordinate of this on x-axis and y-axis? So how do we write cat? It's 3, 2. That is the position on this axis that we are having, 3, 2. What about dog? The dog is going to be, what is the position of this? The dog is like 2 by 3. Okay. So what we have done, we have just noted the position of them. And this is like 2 dimension. We are just putting it here. What if I increase one more dimension? Then it will shift somewhere in between here. This will also get shifted here. Now this will be having 3 numerical values. One would be x-axis, y-axis, and third would be z-axis. So maybe like something here like it was in between. For example, I keep here as 4. Okay. Dog would be like this. It would also be having one extra value here based on new axis that we have got. So this will also become like, maybe here it is again 3, for example. Okay. So what is this? From 2 dimension we shifted to 3 dimensions. So embeddings, basically what are embeddings? Embeddings are the words, tokens basically thrown away in n dimension space. Now if I say 200 dimensions, or if I say 300, so what will happen? Then you will be having words like 2, 1, 3, dot, 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 200, such sort of values there. Okay, like this. So any idea what is the dimension of chat GPT embeddings? Anybody's having idea? How much? What is the dimension of that? Any rough estimate, any rough idea? What is the dimension of OpenAI chat GPT models? 587. Okay. Any other guess here? 1536. That is right, Priya. So total, there are two models in GPT itself. One is small and one is large. So if you check on their website, they have mentioned this. So if you go to embeddings, if you go to their embeddings, they have mentioned this. There are two models for uh, this. One is small and one is large. So they have these models. They are having this model. So one is a small model, text embedding small. One is text embedding large. And previously, like the first model for embedding was ADA. This is not LLM model. This is how do you convert your data into an n dimension vectors. So these embedding models, they work in that way. And if you notice here, they have written this. What is the dimension? Yeah, it is here. So if you notice, a small model is around 1536. A large model is 3000 dimensions. So what it means, you're throwing away the word in n dimension space. And I can give you example for that. We have these TensorFlow projector, very beautiful, visualization of this. If I open this, so you can see these words. This is like embedding projector. So every word in n dimension space now, all these words are actually here. It is in 200 dimensions, but that has been compressed by using a machine learning technique into 3 important components. Right now we are having, like you can see a green color here. There are 3 lines. For example, if I say this word happy, like if I search this word happy here, so you may notice all other words related to happy. So this is like you throw away the words in n dimension space, and the words which are very close to happy, you will see them around this. Okay, like all these words which are similar to that, they will be coming together. The words which are not similar, then they will not be away. Like all these words, if you see, like here quantum, trucks, they are away from happy because they're not related. And if I pick up these words, like some new word, if I pick up from here, all words that is related to that, I would be able to find, like transaction. So all words related. So like this, you can play with this, you can see. So this is embeddings that we are having. So initially what we are doing, any data that we are having, we are doing chunking. Okay, we are doing chunking first. We break it down into small tokens, which we call it as chunks. Then we do embedding. Just now we discussed that embeddings. So your data, whatever data you're having, whether it is text data, whether it is images, audios, videos, whatever it is, you will create an embeddings of that. And once you create the embeddings, then you would be storing it. Like you have to store these data somewhere. So where do we store them? We store them into a vector database, where it is storing all these different dimensions data together, and it is faster for indexing. We can do faster indexing. So this is slightly different from traditional databases that we are having. Okay, so we store all the data into a vector database. Now here, when you store your data, now suppose a user is having some query, he's typing something on chat GPT, or he's typing something on the UI. Okay, this user is trying to type there something on the UI. That text also, it has to be converted into same embedding what we have done. That text will be converted first into this embedding, and it will come here and it will try to search in this database. Okay, so when it is doing the search, that is called as RAG part. That is a retrieval part. What is meaning here? In my database, I'm trying to retrieve the information. I'm trying to search that information. I'm trying to retrieve that. And once you retrieve that information, so that stands for R. R is the retrieval part. Now, once, let's say in my document, I was looking for leave policy. So I was having 10,000 pages document. Now in 3 pages, there are some description about leave. Page number 100, page number 150, for example, and page number 200. So we got these 3 pages. Now our answer will be in any of these 3 pages. So the next part is taking these 3 pages and our query and putting them together. This is called as augmented. That's what you see here, the green color. The yellow color was retrieval part. The green color that you're seeing is a augmented, where you, whatever top search we have got from RAG, like we can define top 3, top 4, top 5. We take it here, top K. That is coming from RAG, basically the retrieval part. And then we are taking those top Ks along with the query, the prompt that we are having. We put them together and we send it to LLM, that is the generation part. A large language model is doing the generation. So it could be any model in the backend, GPT model, Gemini model, Claude, any model that we are running that would generate a response. So this is a basic architecture of a RAG end-to-end, how it is working. So this is what we saw in that diagram, how RAG is working. We discuss about first, when a user is asking the question, the system first retrieves a relevant document or data from the knowledge base. That is a vector database. Then it is doing augmenting, like it is adding the whatever top case search has been it found here along with the prompt as a it has to give a context. So the prompt is going as a context. It goes to LLM model. The LLM model, it is receiving those contexts, the original question that you asked, top case searches, and basis of this, it is going to generate the response. So now one of the problem that we were having about external knowledge on the LLM, that problem is solved here. Okay. But again, here RAG is having some limitation. What is the limitation? It's actually a passive one-shot process. What it means is that it is retrieving the information only one time. As you've seen here, when you're doing the retrieval part that you see here is in green, okay, which all of you see. Now, when this retrieval is happening, sorry, the yellow part that you see, this is happening only one time, okay. If you're able to find top case search basis of, it may happen that in the first iteration that we tried, we have not got the proper response. We could have again searched it. But traditional RAG, have these limitations. So it is one shot process. What it means is that it retrieves information once, and on basis of that, it is generating an answer. Now, it is struggling sometimes when we have a complex multi-step questions that requires to break down the problem. If you're having a very complex problem like some financial ratios, we want to know, okay, what is the EBITDA and all those numbers, let's say from the table structure. So sometimes profitability we are looking for from the balance sheet, sometimes it may struggle to give a proper response, and this is one of the very common problem with RAG. Okay, one problem is sometimes it is not able to extract data properly from PDF document, OCR document. To a certain extent, we have solved that problem by using certain applications like docklinks and all, where it is doing very good job. It's basically how we are pulling the data from other formats. But then main challenge here is that how do we retrieve a proper information from the vector database itself? It's a challenge here. Now we have understood this, what is the limitation of RAG. Now let's try to understand what are the AI agents. So when we talk about AI agent, what is the AI agent? So AI agent is made up of four important things. What is AI agent? AI agent is basically made up of four important things. If I want to explain you that what is the AI agent made up of, so we can think about like these are the important thing of any agents. 1 minute. Yeah. So this would be the important thing for any agent that we are having. Like, what are agents? Basically, if you want to understand this, what are agents? So agents are nothing but agents are made up of the following thing. It is made up of a prompt. Okay. It is made up of LLMs, large language models. It is having some sort of memory and some sort of tools. So agents, basically we can put them into, it is made up of four basic things, four basic ingredients. What are the four basic things which make the agents? One is a prompt. What is prompt? Prompt is a instruction. It is a text. All of you might have used ChatGPT. You might have written something. So when you are trying to write some information, maybe write some text here, and then you're trying to retrieve some information. So you might have written some prompt in ChatGPT. Sometimes you define a role, like think like a financial analyst, think like an manager, think like an admin. So what we are doing, we are giving it a role here. So agents, when we are building these agents, so we also build like sales agent, an HR agent, medical agent, like that. So you can give a role here in the prompt itself. Now, the next part is that we need the large language models. We need the large language model. So this is connected with the LLM models in the backend. Okay. And it has got some sort of memory. We have some short-term and long-term memory for storing the information, for retrieving, and some tools. Now, how are the agents different from LLM models? You may ask that, why do we need agents? Simple thing is that the GenAI models, okay, the LLM models, they have some limitations. I give you example. If you want to go on a vacation, you can go to ChatGPT and say, prepare a travel itinerary for Paris for 7 days. It will give you a beautiful travel itinerary. Day one, morning you arrive and then you can, go to this hotel, and then morning, afternoon you can visit this place. You can go to Eiffel Tower and then this market and all. Now, if you ask ChatGPT to go and book a travel ticket for you, it cannot do that. It has certain limitations. So that is where we need some tools, some applications which can do the end-to-end task. So some applications, some tools which can even go and book a flight ticket, book a hotel. So that is where we need the agents to complete all tasks end-to-end. So now when we talk about agents, like what agents do. So agent, very basically, there are certain terms that we need to understand. Agents have a feature called as react. Now this is important. What is meaning of react? React means to reason and then to take the actions. Now how is the agent reacting? Agent is just a prompt. We are defining a role. So what it does, it uses the LLM itself, the large language model, wherever the agent is there, to reason, and then once it is reasoning, then it can take certain tools and it can work on those tools. Okay. So the agent can reason first and then it can use certain tools, like you want to scrap some data from Wikipedia. So you can have some web scrapper tool to get some data. You want to scrap some stock market news right now, maybe today morning or yesterday. So you can use those scrappers to get the data. So how are the agents taking actions? By using some external tools. Okay, these tools are different types of APIs which are linked to that, like searching on Google, retrieving some information. So we have got different types of tools available here, which is used to retrieve the data. So what are agents made up of? Agents are made up of these following things: a prompt, which may be having a role defined to that, LLM model itself for reasoning purpose and for generating the tokens, memory, memory to remember the previous events, okay, and again for reasoning purpose also, storing and giving some sort of memory here to look into the data and store it somewhere and process the information, and some tools basically. So these are the agents. This is what we discuss. So what is an agent? Agent is basically an autonomous system which perceives in the environment. It reasons. So we talk about that react. Okay. we talk about the React. What is React? Reasoning. How it is reasoning? By using LLMs. Okay. So it can reason about the goals and take actions. How it is taking actions? By using some tools available there. Maybe connected with some external tools that we are having. So what you see here is a React framework of agents where first of all, it is reasoning. How it is reasoning? By using LLM models. It is trying to decide what is my next step. And then we have the actions. How they are using the actions? By using the tools like a search engine, maybe a calculator, maybe a code interpreter that we are having. We are trying to interpret certain codes here. And then once the agent is receiving all this information, then it can do the actions. Okay, so you can see here how these agents work. So they work in a React framework. We also have one more framework called as COT. This is called as chain of thoughts. Chain of thoughts means one reasoning and then next and then these are like chains which we are having. So chain of thoughts, COT is again similar to what we are doing in React, reasoning and acting. So one thing you will find here, uh, common here is that it is reasoning, it is thinking. Okay, that is one thing. Second thing, it is taking actions. So this is a agent framework that you say. So his thoughts takes action and observe. This is like a loop unless the agent has got the complete information here. Okay, anybody is having any question? There could be TOT, like there could be different things. I'm just giving example. Most common like COT, TOT, you will have all those things. But React is a very basic thing that we are using here. Okay. Now, what we are doing? Now we are trying to bring an agents along with the RAG. Now, why do we need that? So you can see here, we discuss about standard RAG. Here we are having the standard RAG. It's fixed it. So when we retrieve that data, we saw that okay, it is doing one-time retrieval, okay, and generating that information. It's a single retrieval activity that we are having. It's a passive process, and sometimes the context that we may get here would be limited. In agentic AI, what is happening? This is not fixed. The agents can keep on trying. Remember, we discussed there's a loop where it is trying. So if you remember, we discussed about a complete loop where these agents are trying. So if I go back, you can see this is the complete loop. Thought, action, and observation. This is a loop. So unlike what we are having in the standard RAG, here it is more dynamic. It is more dynamic. Agents, they are driving the workflow. Like they can keep on coming, and they can do multiple retrieval. So this was a challenge. Now this is being solved by using Agentic RAG. Agentic RAG will be doing this multiple retrieval. Okay. And then we have these active process decision making because they can reason okay, using LLM models and they can retrieve further and that will generate more response based on the context that we are having. So, and then the agents can decide using LLM itself whether what is more relevant or not. And then they can use one of the many tools that are there. So you can see agentic AI is actually getting combined with RAG. So uh, just by using simple RAG, we are trying to bring the agentic capabilities to the RAG. Okay. And because of that, whatever limitations the RAG was happening, okay, it is much more improved. So the LLM powered agents, they can decide what, when, and how to retrieve the important information that we see here. So what happens here? It makes the decision dynamically. It can retrieve multiple times and it can use the reasoning also. Like it can use reasoning to guide the process. So it's not just reasoning, it is generating and generating in a better way by using a loop. And that is why agentic RAG, becomes a better application, better solution, giving us better output when we are using this. Okay, so how does agent work? Like how does this RAG works in the loop? Now think about it, like if you're using these MacBooks, okay, you want to compare some features of these chips. Let's say you're comparing M2 with M3 or maybe M4 pro chips that we are having, and then you want to understand which one is better for video editing, okay, for professional review. So we want to compare the key feature of these two different machines, M2 and M3, pro version, and then we want to see which one is better. So what like what standard RAG will do? It will just perform a single retrieval operation. It will go and try to retrieve here, and then here what will happen? It may retrieve document about M2 M3 separately. It will go and find, okay, where we have information about M2 M3, and then that information, that document, okay, it is going to synthesize and send it to the LLM model for generating. So it cannot target a specific aspect of that. Okay, so this is a limitation that we are having. Okay, and limited to the quality of initial, like whatever attempt it made, the first attempt is the only attempt we are doing in RAG. So it's standard RAG I'm talking about. So whatever data we retrieve first time, it will try to find everything there. So if you try to understand in agentic AI what is happening in agentic RAG, basically it breaks down the query into logical component, and let's say it is trying to compare them. So first it will try to formulate a targeted search tool. How it is going to search for everything? It is going to retrieve the relevant information that it needs. So the agentic RAG, what it is doing, it is actually unlike the RAG where it is trying to just do a single retrieval. It will break the query into parts, and then it will perform targeted search for every part, okay, for specifications, for reviews. In a standard RAG, we don't have this targeted approach, okay. Here it will do a better way. It will do a targeted search for the specifications of maybe M2 or M3. Look into the reviews, and then it is going to combine everything, all the information in a proper structured and reliable information. So agentic AI would approach this complex query in a very systematic way through multiple operations and reasoning, and that is what is lacking in the standard RAG. It is actually much better that we are having. Now we have understood the difference between standard RAG and agentic RAG. Now let's try to understand what is the workflow here, how it will be working. So if you look at the workflow, the first thing it is doing here, it is agentic RAG or chain of thought is agentic using React. Agentic will use React or maybe chain of thought or maybe TOT, whatever you are having. When you are creating this agent, you have to define how I'm going to use that. Okay. So you have to define the workflow, like whether I want to use React, whether I want to use chain of thought, that is up to you. When you're designing this entire workflow, you have to decide that. Now in this example, you see, we were comparing M2 specification with M3 specifications for video editing reviews. So the first thing, how this RAG workflow works is that it will break down the problem. So first it will plan, it will identify the subtask. So first thing it will plan, okay, that is the thought process here, identify subparts, okay. So it will first go and see what are the subtasks. Subtask could be looking into first M2 Pro chips, looking into specification for that. Then one subtask would be, now you only look for M3 Pro chip. So one time you focus on M2, one time you focus on M3. And also one part would be you are looking into the video editing reviews. So find the reviews comparing both of them. So maybe three tasks we are doing. We are looking into specification of M2 chip. One task would be looking into specification of M3 Pro chip. And the third task would be looking into the reviews of video editing for both of them. So this is the planning part. The first part is planning part that you are having. Now we have done a planning, that is a thought. Then the next step is action. So this is action, this is action. This was planning that we have done. Now we are going to execute the first action. What is the first action? Go and search on internet. Go and search about specification about M2 Pro chip, either on the document or wherever it is. What are the use the retrieval tool to search for M2 Pro chip information? Okay, that is one action. Then what is the next action we are having? The next action would be like look for specification of M3. So here we are using the retrieval tool to query about technical specification of M2 Pro chip. Output would be the observation would be that the agent will be getting all these detailed information about M2 GPU, CPU, memory, everything. Here in the next step, the next action we are doing, because we have the parts here. So we are going to search for M3 Pro specification. Also we are going to search about action about video editing. Okay, so you can see this is here we are doing the action for the first task. This was our first task, okay, that we have defined. We are doing the first task action here. Second task we have defined here. We are doing the action for the second task. Third was to look into review. So this is our third task action. What we have done, the entire problem we have broken into three subtasks, and then we are doing one by one. We are doing all the subtasks. So starting with first action, you go for check for M2. Second action, you go and check for M3 Pro chips. And the fourth one is that you try to look into the video editing reviews. So here they would be performing that, reviews, and where, like, unlike what this step 2, step 3 is doing, where the query is more about, some sort of technical specifications, here this is more about professional reviews about both of them, okay, where we would be having some more discussion. This would be retrieving some information about the comparison of both of them. And after you have done everything, what is the next step? The next step would be to compare. Okay, step number 5 would be, okay, you got action 2, you got information search uh, results for M2 Pro specification, then you got again search results from M3 Pro specification, and then we also got some sort of editing performance reviews for both of them. Now we have got all these information. What we are going to do, all the specification informations that we have got, now you can construct your final answer. So what will happen? Agent was using a tool when it was doing that action. What we saw, action 1, action 2, action 3. How were those actions done? Those actions were done by using certain tools. We are using certain tools for doing those actions. Now it is going to stop using the tool and it is going to generate an answer by using the large language model, by focusing on the feature and then giving a summary of the reviews and all. So now you can see, you can understand how agentic RAG is a much better approach, okay, and it is also able to solve certain problems, certain limitation which the normal RAG is having, okay. And then what are the key features that we are having? Like here, self corrections, what it can do, it can do self corrections. Like this is not possible in normal RAG. The key strength of the very important feature, the key strength of agentic RAG is the self corrections. The agents they can detect the irrelevant result. If the result is not proper, okay, it is incomplete, it will again go in the loop, okay, try to find it once again. If there is some sort of ambiguities in the output it is generating, it is going to find it out those ambiguities in the query, and then what will happen? Again, it may highlight that. It has to reformulate the search strategies. Okay, so it has to reformulate the search once again. Maybe some ambiguous information was there. That's not important. So it has to go and search again. Maybe it found some irrelevant information. So it has to search again. And then it can also it can ask clarifying questions when it is needed. So what happens because of this? This makes it, very, very robust, as well as it becomes very reliable for any complex or maybe ambiguous query that we are doing here. Does it mean, okay, there's a question, does it mean that there will be less? Definitely, there is going to be less hallucinations when you're using agentic RAG, because here we have that self-correction mechanism. In normal RAG, we don't have these self-corrections. So it can actually detect the irrelevant results. That is the hallucinations. Okay. Some sort of, so it can reformulate the strategy, go back, search on internet again by using React mechanism, and maybe give us a proper output based on whatever query that we have done. Now, if you see here, we are just talking about how this self-correction happens. An example of that. How do we control different actions to take place? You don't have to do anything. The agent will take care of everything. Okay, that's what, we have an autonomy here. We don't have to sit down and ask. They are capable enough of, taking care of this. So, for example, like if you have a question here, what was the impact of Big One on California's economy? Now, this is the question. What was the impact of Big One on California economy? So what will happen? We have this very ambiguous question. Okay, very, very ambiguous question. Now what will happen? Now, what the agent will do initially, it is going to search. So agent will initially search about this. It will go and search about this first. Impact of Big One on California. So it will go and search like how normal RAG is doing. But then what will happen? Then the agent will realize that, okay, that oh, it is actually searching something that's a very vague kind of thing. What is Big One? Nobody knows that. Okay, so here it will go and say, oh, this is some vague, question. There is no concrete data is found here when we put these kind of questions. Now the agent has realized that this Big One is actually a vague question. What is this Big One? It's a vague question. Then what will happen? It is going to adapt. It is going to adapt itself and search for, major, what are the major big past, maybe like major big events, because this is ambiguous, okay, and may refer to future. So what will happen? The user might be referring to some past, some sort of event. So it will go back and see what was a very big thing, maybe in California, maybe like recent earthquake, for example. Okay. Again, so, or maybe some event that has happened. So it will go and look into that. For example, now here it got some context about earthquake. So it will go and search most recent, earthquake in California. So from ambiguity, Big One, what we got somewhere. Okay. And then it may look into the document and try to generate. So the agent initially is going to search for this ambiguous, and then it is going to adapt. Okay, it is going to adapt itself. It may even ask a question back to us, whether you're looking for an earthquake only or something else. It may even ask a question back to us so that we give a proper context, and then maybe it will try to proceed and maybe clarify, with the user that okay, this is what I'm looking. So most important thing, even after completing this, it's going to ask for a clarification, for a final action, and the agent, either ask the user, like, are you referring to this, earthquake, or maybe, no, what is the exact reason here? So you can see how these agents, when we are using RAG, they are able to handle the ambiguous questions, which would be there, better way. Now here we see the comparison of a standard RAG and the agentic RAG. So if you look at the process flow, we saw this. This is from retrieval to augmented to generation. That is what we were having here. Okay. Here, this is iterative. First, you think, okay, divide into subtasks, take an action, and do an observation. And this is a loop. If the output is not proper, again, this will be looping. This will continue. This is when you talk about query handling, this is for simple factual questions. This is more important for a complex task, multi-hop you want to do, or maybe you are having some ambiguous question there. You want to respond to this. So this is going to be very, very useful there. When we talk about retrieval, here only one query is retrieved at a time. Here what will happen? Multiple retrievals, and then we can define. Again, if you want to go and decide to search again, you can do that. If you see the strategy here, this is more passive. It simply fetches off what looks relevant. So it will see what is relevant, what is not. This is active. It plans what to search. Okay, what I want to find out. It is going to evaluate the results and then again redefine the strategy. It's going to redefine the strategy on its own. We don't have to tell anything to the agents what to do, what not to do. So you can see, you can understand here. This is having much better because it can evaluate the output. It can see whether the output is good or not. Again, if I want to redefine it, it will try to refine some strategy, maybe go back. That loop is always there further. Now, when we look at error handling, this is limited. If retrieval is the main focus here is on the retrieval part. Whatever you retrieve is very important. Suppose if the retrieval is not able to get a proper information. Suppose I was asking for uh, HR policy, maybe leave policy. Now, it is not able to find the page number properly, page 100, page 150, 200. It is getting something, page number 500, 600, and that is not very specific. Then the entire output is going to be totally different. So here, generation may not give us the output that we are expecting. It may start hallucinating. Here, what is happening, if this kind of problem happens, the agents are able to identify that okay, this is failing here, we have to improve that, and then we have these self correct with some sort of new queries. They can go and they can correct. So if you look at the role of LLM here, this is just for generating the text. The LLM here, what it is doing, the LLM here is doing only the generation part. It is able to generate the text. Here it is used for reasoning, brainstorming. Like example, the agents try to define the task, subtask and all. So basically you are using the LLM agents for doing all these things. So this is going to be, much more refined, much better output that we are having. Now, if you look at, what are the key advantage of Agentic RAG? Why should we use Agentic RAG? Already we saw that, what happens. So it is having a deeper reasoning. It can handle multi-steps. So multi-step tasks that you are having. So it can solve a problem that requires planning and synthesis across multiple information sources that we are having. The agents, they can decompose the complex queries into some sort of meaningful subqueries and maybe develop some sort of strategy to handle that in a step-wise way, in a step-by-step manner, like sequential way. Here, the accuracy is improved. So, like example, it will go again, retrieve the information, look at that, and maybe again try to modify that, validate that. So what happens by formulating a precise search, any specific information, piece of information that we need, we can retrieve here and we can validate, like it will validate the quality of the retrieve data, whatever is there. And because of this, what happens? The risk of hallucination is less here. This is more robust. It deals with ambiguity and failure very easily. Okay. And when a search is insufficient, agent can reformulate strategy and see what are the other ways. We don't have to tell it. It will go and try on its own. And the most important part, flexibility. So we have so many tools, like you want to use it as a calculator, you want to use it as a API, you want to retrieve some text. It can do that. So agent can be used as a calculator, code interpreter, or API, where we can use it for multiple problem solving. We can do a lot of operation using that. So you can see the capability of agentic RAG is much better compared to what we are doing. So how do you control the different actions that again takes place? Maybe many. So different, see, we have for action, we are having different tools. So when we are creating that, we create those actions. Okay. When we are creating those agents, we create those actions. Yeah. What tools are used in the so tools like you want to search on internet, so you would be using Wikipedia tool, Wikipedia SERP tool. We are having tools like SERP API, which is how Google is working. It's an API tool for searching on Google. You can use a mathematical tool, a calculator tool to retrieve some part of information. Okay. And then we can see like what kind of advanced reasoning, what are the use cases we can use. So you can see like agent can read multiple research paper. It can compare their finding with and then generate some literature review. So it can do initial search. It can go to the database, look into the research paper, topic that we select. We can select the paper. Okay, so agent can see how important. So it will search for the academic paper. It is going to evaluate the relevance and the impact of those paper. Then it will find out, okay, evaluate some sort of methodologies and finding, compare, it will do a comparative review. So it will try to see what are the contradictions, what are the patterns there, and then it will generate a structured review that we are having here. Okay. So again, like agent workflow we can use for solving complex data analysis we are having. So like we are having some sort of dashboard we are looking there, so we can use it for those kind of things. We can use it for enterprise knowledge system use case. For example, like imagine an employee is asking that how do I set up the development environment for my project, and how do I follow the security protocols. So it will help with some sort of searching the technical, like what are the technical instructions or the steps, looking into the organization security documents for helping with the policies, and maybe combining both of them and giving a proper actionable answer here, okay, for onboarding and compliance. Okay, so that was from my end. We had a lab also, like just to show you all what is happening here. Maybe I would not be able to run it right now, but this is using Crew AI. You can see here. So we have these PDF research tool. Somebody asked me Tavily search. So we have these Tavily also for searching on the internet. Okay, these are two tools that we are having. We can use OpenAI, and we can use uh, certain frameworks like agentic frameworks like Crew AI, which is very good for doing certain tasks and all. So these are the libraries. You do the API setting and all for this. Let's go down and check. Okay, so here we do all these. We set up the PDF search tool. Okay, model we can use like Llama model. We can use. We can configure everything. We can set up the RAG tool. Like I have some research paper. I want to ask a question. Okay, you can ask the question from your data itself, or maybe you want to search on internet also. I want to ask about what is attention mechanism in my PDF. Okay, so one question I will try to retrieve data from my PDF, and then like for example I have this PDF here. I want to find out from this PDF. Okay, this is my PDF. I want to find out what is the attention mechanism. I want to get a response for that. So it will try to look into this PDF and try to find what is attention mechanism. Okay, I will try to respond to my queries basis of that. That is one thing you can do by using a RAG tool. Also, you can use the Tavily API that we discussed tool to search on the internet, and you can see. So we are using the tools. And basically, how does it work? So in agentic AI, we have a role. A role, as we discuss, every agent you would be giving some role in the prompt itself. So here, if you see, we are giving a role. We give a goal like what it has to do. It has to question, it has to route the question to the vector store. We give a backstory. This is your prompt. Like you're defining it with the role. Your role is of an expert asking some questions on vector store database and search. Okay. So you define one agent. This is a router agent. One agent would be a retriever agent. This is going to retrieve the information. So you are an assistant for question answering task. Use the information that is there to retrieve some information. And then you have a grader agent. You can say it is going to grade the answer. If it is not good, again, it is going to route back. And you also have a hallucination agent, which is going to look into hallucinations. We have one more agent, answer grader. So they will be working together. As you can say, this is a big example. And finally, they would be able to generate some response. I may not be able to run it right now because it needs some time. But anyway, I will stop here. I hope I was able to explain Agentic RAG to all of you. Maybe if you have some questions, I can answer that. Okay, so you mentioned that we can use vector database. I need somewhere SQL database or work. See, SQL database is fine, but then that data is not in a format that model will understand. The LLM model will understand. Somewhere that conversion has to be done, and that is why it's important here. Uh, Demo links and all, we are having some workshop coming up. You can join them. Okay, we have some course on agentic AI. If anybody is interested, you all can join them. So I would stop here. Sai, if you want to continue further, you can take.
Uh, Yes, hello. Thanks for your insightful session. Yeah, we have came to an end today for this session. And as a token of appreciation, today our AgileFever CEO has given an exciting offer for us on AgileFever. Like we are offering as a token of appreciation around 10% off on all our courses. So if you are interested in AgileFever AI courses or any of the courses in AgileFever, you can avail that offer. And yes, thanks for this insightful session, Alok. And yes, this is the end to the session today. And you can join to our LinkedIn channels and YouTube channels for the recordings. And Alok, they are asking for PPT. Is it available?
It's actually okay. So PPT, let me see. I'll share you some material for this. Okay, whatever.
Yes, yes. Like, yes, as Alok said, like we will be sharing this as an LinkedIn post. If you can, if you are okay with that, you can check that on our LinkedIn pages.
Yeah.